Welcome to Manimated AI. In this video, we're diving into determinants at first. They might just look like another formula, but they're much more than that. Today, we'll build intuition, then compute a few to see it in action. So, what is a determinant? Think of a determinant like a special number we get from a square matrix. We denote it as determinant of a, or bars around a. Now, geometrically, that number tells us how much the matrix stretches space. Let's keep this super simple. The determinant of a 2x2 matrix tells us how the matrix scales area on the plane. If the determinant were 0, the picture would flatten. Otherwise, it stretches or flips space by some factor. Here's a matrix. A equals 4, 0, 0, 3. We'll start with the standard basis arrows, I hat and j hat, and the unit square in the corner. That square has area 1 before any transformation. Always remember, the determinant is how space scales. Say it with me, the determinant is how space scales. For this a, the determinant is 4 times 3 minus 0, which is 12. Now, watch the transformation happen. The x direction stretches by 4. The y direction stretches by 3. The unit square becomes a rectangle 4 by 3, so its area scales by 12. And that's the determinant in action. It shows us how the area scales and whether the space flips or not. Now, let's see how we can actually calculate it. Let's start at the simplest case, a 1x1 matrix. If it equals the 1x1 matrix bracket a 1, 1, then the determinant is just that single entry. We write D equals det of A equals a 1, 1. So, the determinant just reads off a 1, 1. For example, if A equals bracket 5, the determinant is 5. Geometrically, a 1x1 matrix just multiplies numbers. So det A equals 5 means lengths scale by 5. The unit segment from 0 to 1 becomes a segment from 0 to 5. If that single entry were negative, the number line would flip direction. That's the determinant for a 1x1 matrix, just the entry itself. Now, let's compute the determinant of a 2x2 matrix. For a 2x2 matrix A, the determinant is A11 times A22 minus A12 times A21. Multiply the downright diagonal, then multiply the upright diagonal. Finally, subtract. For example, with A equal to bracket 3, 8, 4, 6, the determinant is 3 times 6 minus 8 times 4, which equals negative 14. Notice the negative sign. A negative determinant indicates a flip in orientation. Now, let's look at the determinant of a 3x3 matrix. We will expand along the first row using cofactors, which follows a plus, minus, plus pattern. We all know this is a 3x3 matrix. For simplifying, let me show you like a table, so I can explain the formula in a better way. Here is our 3x3 matrix. Entries a 1, 1 through a 3, 3. Cofactor expansion along the first row uses signs plus, minus, plus. First term, take a 1, 1, then delete its row and its column. The remaining 2x2 is the minor. Its determinant is the downright product minus the upright product. Second term, subtract a 1 2 times its minor. Delete row 1 and column 2, take the 2x2 determinant, downright minus upright. Third term, add a 1 3 times its minor. Delete row 1 and column 3. Again, downright minus upright. Putting the three terms together gives the full formula. Plus a 1 1 times its minor, minus a 1 2 times its minor, plus a 1 3 times its minor. Let us see an example. Let's see a 3x3 matrix. We will expand along the first row. 1, 2, 3. Here is the cofactor expansion. Plus, minus, plus, each with a 2x2 determinant. We'll simplify each term. First term, 1 times 24 minus 0 equals 24. Second term, subtract 2 times 0 minus 5, that is minus 2 times negative 5, which is 10. Third term, plus 3 times 0 minus 4, that is 3 times negative 4, which is negative 12. Now, add the three results. 24 plus 10 minus 12 equals 22. Remember this video. We learned that determinants scale space. For 1 times 1, it's the entry. For 2 times 2, it's add minus BC. The sign tells stretch or flip, and for 3 times 3, we use the plus minus plus rule. From mystery to mastery, next we will uncover eigenvalues and eigenvectors, what they are, why they matter, and how to find them with visuals that make it click. Thank you for watching. Don't forget to like, share, and subscribe, and we will see you in the next episode. Stay tuned. This video is made by Astha Joshi. Keep learning, and I'll see you in the next video.